Going. Don't say anything dumb. I knew as soon as.
I almost said anything dumb.
Oh, that would have been a good one too. Okay. Okay, M.2 multiply matrices. So there are two different ways to multiply matrices. We already learned one yesterday. So there's scalar multiply. And this will take up like a very small portion of your notes because the other part is going to be a lot bigger.
No, my Tetris.
Yeah, we already talked about scalar multiply. So we'll put one more example here. What should our scalar be?
0. You should have a 0.
Okay, we're going to scale by 0 because Autumn told me to.
It's not always 0.
What should the dimensions of my matrix be?
16.
37 by 40? I don't think so. What should we do?
0.
1 by
1.
1 by 1, we can do it. Okay. Eva told me 2, 4, 3.
4, 7, 5,
0, 9.
3, 1, 4.
Negative
Yeah.
700.
Negative 720 would have been a good addition. Okay, so we have a 3 by 3 matrix, and we're scaling it by 0. So when we scale it by 0, we're left with 0, 0, 0, 0, 0, 0.
Wait, can I guess the next one?
Yeah,
I think it's going to be 0.
yeah, 0, 0.
Wow.
So we literally just distribute it into every thing. Now, so this, we actually do call it the 0 matrix, and it is useful to us. Yesterday in the video, I talked about how, well, actually, I guess we did talk about the 0 matrix in the video yesterday, didn't we? How, like, in normal numbers, if I were to do, like, 5 plus 0, the plus 0 doesn't really do anything, so it just leaves us 5. So if I were to add, like, any 3 by 3 matrix to this matrix, it would just be the same thing, right? So it doesn't do anything. So it does kind of have some special properties, but that's it. That's scalar multiply. Any questions about scalar multiply? Okay, you just distribute it into everything. Okay, this is going to get wild. Are you ready? So we're going to do an example where we're going to multiply a matrix by a matrix. And we are going to multiply, I'm making this up. Negative 1 to what?
What's the name? What's it called?
Regular matrix multiply. Let's say we're going to multiply 2 by 2. Oh man, this is going to look dumb if I write 2 by 2 times 2 by 2.
Just do a dot.
Scalar multiply and regular multiply. We don't really have another name for it. We just call it like matrix multiplication. We normally we'll say specifically if it's scalar multiplication, but other than that, this is just regular multiplication. Yeah.
So does the matrix have to be the same?
It does not have to be the same size, but there is something about the sizes that has to match up, and we'll talk about it in just a second. But we can multiply a 2 by 2 times a 2 by 2. So here's a 2 by 2, 4, negative 10, 1, 1. Okay, cool. So we're going to multiply these two matrices together. So you can imagine there's like a dot right here in the middle. Multiply dot. Okay. The output is going to be a 2 by 2 matrix. I'm just telling you that. When you multiply two 2 by 2 matrices, the output is going to be a 2 by 2 matrix. But to get the ingredients, it is not as nice as it seems. It is unfortunately not negative 1 times 4. Yeah, sorry. I need a highlighter. What we have to do, it's actually kind of like taking the dot product. Remember when we did the dot product with vectors?
Yeah.
Okay, well, I broke the smart board, so this is really going well. Oh, okay, there you go, highlighter. Okay, what we have to do is we're going to multiply this, we're going to dot product this row with this column, and that answer is going to go right here.
Why?
Whew.
What's the logic?
It has to do with something called linear projections, which we're going to talk about tomorrow. Sorry. For right now, you're going to have to believe me for a second, and we'll talk about it. But, so I have to do negative 1 times 4. I'm just going to, like, write it out in here, like the whole thing. Okay, so that first one is going to be negative 1 times 4 plus 2 times 1. So I have to do negative 1 times 4 plus 2 times 1. That's the first entry in our like product matrix. So the second, like this top right corner is going to be, can I switch my highlighter? Even though it does. The second one is going to be the top row and the right column. So it's kind of like where they overlap. Like if you could put them over each other, it's like the top row and the right column, they overlap in that top right position. So that's going to be this answer.
So you just do their row and their column and you dot product that.
Yes. Okay, so this one is going to be -1 times -10 plus 2 times 1. That's that entry.
Hold on. What?
So -1
Why do they go where they go?
times -10. Why did they go where they go?
Yeah, why am I multiplying -1 and -10?
-1 and -10. 2, 1. So this is the first row, second column. So it goes in the 1, 2 spot.
So like first of the first row, first of the second
Yes.
column, second of the row.
Yes.
And if I had more, I would continue with that.
And if you had more, you would continue with that pattern. Okay, with your partner, Anderson, would you figure out what the like bottom row should be? What those dot products will be? So you need to use the bottom row.
You still do columns or do you, yeah.
So you're gonna use the bottom row and then the first column to get here. And then the bottom row and the second column to get here.
What's 0 times 4? Oh, wait a second, it's 0.
Here we go. 0 times -10.
So you have to use the bottom row.
We go 0 times -10.
Oh, you got it. Yes. That is smart.
And then it'd be 0, 3. I feel like she's writing it in like the letters instead of with the numbers. So it's like more generic.
That's a good idea.
A lot long. This week's gonna be slow.
Okay,
I just got 0.
okay.
Why?
So let's like this bottom left-hand corner. The bottom left-hand corner is gonna be the bottom row and the first column. So 0 times 4 is 0, right? 0 times 4 plus 3 times 1. And the bottom right corner is going to be the bottom row and the second column. So 0 times -10 plus 3 times 1. Okay, that looks really gross. So let's go ahead and write what that actually equals. -1 times 4 is -4 plus 2, so this is -2.
Yep.
-2. This is 10 plus 2, so this is 12. 0 plus 3 is 3. And 0 plus 3 is 3. There we go. So that's our actual answer. -2, 12, 3, 3.
So does the commutative property apply to this? If I switch them around, would it change anything?
It would. So multiplying matrices is not commutative. So, and we've done like 2 times 3 is equal to 3 times 2. They're both 6. Does not work for matrices. Matrices are the first example of something that is not commutative.
First versus last, like if I was reading a word problem, how would I decide?
You probably would not be given a word problem with matrices. in it.
Yeah.
Yeah.
What if I
We'll
was
never have
like
like maybe.
computer coding, I need to multiply them, how would I decide?
You would have to know, like, you would have to know which one. Then you'd have to hard program it to make sure that it was this one times this one and that your order was correct.
They're not gonna give you like, they're gonna show you.
Yeah.
They're not gonna
So-
tell you.
It would depend. So I talked about how this is something that happens more in linear algebra, and it has something to do with something called projections. And so once you know what these projections are, it's like messing with space and time.
Explanation at the state of the unit, or do I
Yes.
just have to like sit and watch?
No, we're gonna watch. I have something to watch about it tomorrow, which it's still like, we're still just like barely touching the surface. Like you like really won't know a lot more about matrices literally until like taking linear algebra in college. Like this is like way out. Do you have to take linear algebra in college? No. Aw. That made me sad. You'll have a lot more math experience before then if that's what you're planning on going into though. Yeah. So, okay. So, a couple of things. We used a 2 by 2 matrix and a 2 by 2 matrix. And we use, what? Oh, you're done for. Also, I am scared and I'm second guessing myself right now. So
Not good.
I'm gonna go check on something really quick.
That's
I
fine.
feel like I might have screwed this up just barely.
My head is understanding.
What?
I wrote in.
But I think I might have messed it up. I really think I might have messed it up. Hold on. Hold on. No, do not touch my whiteboard. I will kill you.
Whoa.
Ashton, I'm guessing that you even did.
What?
Yeah.
Why would you think that?
I laughed so hard when I saw
He
that.
did. It made me laugh.
Yeah.
Thank you for bringing it up.
You're welcome.
Hold on. I did it fine. We did it fine. Everything is fine. Woo. Okay. That was very scary, but everything is fine. Woo, man. Woo. 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 Okay. Yes, go really quick. We're about to do something. Okay. So, man, that was scary. Okay. Okay. Man. Yeah, okay, everything's fine. I got scared for a second. For a second, I thought that maybe we were supposed to do like the columns of the first one and then the rows of the second one, but that is not true. We are fine. We did it perfectly fine. Okay,
First by column for this, tiny columns for this.
right. So we did it right. I just was scared that I ruined your life forever for a second. Okay, so here's the thing. When we went and did the dot product, right? So when we did like this times this, we need to have the same number of things in there so that we can actually do the dot product. So in order to multiply matrices, the inside, so we're doing like 2 by 2 times 2 by 2, the inside, this one and that one have to match in order to multiply.
Just those two?
Just those two. The outsides don't matter, but the insides have to match so that we can do the dot product.
Can we try an example where?
They don't match?
The outsides are different?
Yeah, that's exactly what we're gonna do. Okay. So the outsides have to match, and then the secret is the answer will be the outside dimensions. So our answer was a 2 by 2 matrix. So the outside dimensions, that will be the output. So the insides have to match, and they're kind of gonna like cancel each other out as we do the dot product, and then the result is gonna have the outside dimensions. So let's do an example. We can do a 2 by 3. Let's do a 2 by 3 and a 3 by 4. Or we can do a 2 by 3 and a 3 by 3. Let's do a 2 by 3 and a 3 by 3. Okay, so the insides match, so that means we're going to be able to do the multiplication. Here's our example, a 2 by 3. Let's do 1, 2, 3, 4, 5, 6.
That's
Okay.
scary.
Times a 3 by 3. Times a 3 by 3. What should we put in our 3 by 3 matrix?
6.
6.
9.
2.
Close enough.
1, 7, 3,
4.
5.
Great.
Yes.
Here we go.
3.
Okay. So we're going to do this multiplication. So the inside match, what dimension is our output going to have?
2 by 3.
2 by 3. Yeah, ma'am.
So the dimensions that have to be the same is, yeah, those.
Yep, the columns and the rows. The inside. Because we're about to do this times this, and that has to match up. The same number of things. Right? Number of columns times number of rows has to match for us to do the dot product. Yes, Ashton?
Does that mean that if we were to try and multiply 7, 1, and 4, we would just get 0, 0, 0?
No, we don't be doing it. We can't do that.
I don't, yeah, no. Okay, so the answer is going to be a 2 by 3 because we get the outside dimension. The 2 by 3. The 2 by 3, I'm going to give myself space to do that. Okay, the first entry is going to be found by doing the dot product with the first row and the first column.
6, 2, 7.
This makes more
Pronounce the
sense
big number.
than the 2 by 2 one?
Yeah.
Yeah, so if you have a highlighter, I noticed, I got a highlighter, that's smart. Okay, so this is gonna be 1 times 6, which is 6, plus 2 times 2, which is 4, so we're at 10, plus 3 times 7 is 21, so we get 31. Questionable about doing that in my head. 6 plus 4 plus 21?
That's 30.
31, yeah, okay. So then our second entry, right here. My second entry, right. Oh, I want to move my little circle here, not 31. Oh yeah, my second entry is going to be still the first row, but now the second column. Oh crap,
It's okay. We all fail sometimes.
not okay. Okay, fine, whatever. No, I can't handle that. I need those 3 separate things.
Oh, this actually makes sense.
Okay, then God, it's better with different dimensions. It makes more sense with different dimensions. Okay, that's cool. Okay,
It does actually. It kind of makes
piece it together a little bit more. Yeah. Okay, so now we have to do this dot product. So 1 times 0 is 0, nice. 2 times 5 is 10, plus 3 times 1, so 13. 31, 13. Oh, that worked out good. So this third entry on the top.
Gorgeous.
I want to move this third row. There we go. Third entry on the top is still the top row, because we're still in the top row, but now it's going to be the third column. Mhm. So 1 times 9 is 9, plus 2 times 3 is 6, plus 3 times 4 is 12. 27? 27?
Only the 69 was
Nice. Okay, so now in our answer, when we're looking at the second row, now we're going to be taking from the second row over here, and we're going to start back over here on the first column.
calculator time.
Now we have 24 plus 10 plus 6 times 7 is 42. So 76? Perfect. 76. I'll move it before I write the number. Big brain. Okay. So now we're still in the second row, second column. We gotta do this dot product. 4 times 0 is 0. Plus 5 times 5 is 25. Plus 6 times 1 is 6. 31. Again, interesting. That's gonna move it.
Why have it?
I like it. It shows which one I'm trying to calculate right now. Okay. So now at the second row and third column. So it's gonna be 4 times 9 is 36. Plus 5 times 3 is 15. Plus 6 times 4 is 24. What's that? 75. Nice.
Amazing.
So lots of little calculations. The problem with these matrices, I feel like in general, is there's lots of room for like little baby errors, right? Because if you just add one thing wrong or like multiply one thing wrong and you're adding a bunch of stuff. Okay. Do you want to see one more example?
I think we're good.
Okay, wait, I have one more. For you. You ready?
Okay, it's gonna be short.
It is gonna be short. Let's do what? 10.
Just like.
Yeah, I want the answer to be 1 by 1. So what if I wanted one where the answer is 1 by 1? What dimensions could I use? What can we do?
1 by 3 times 2 by 1.
We can't do 1 by 3 times 2 by 1 because the insides have to match up. 1 by 3 and then 3 by 1, that will work. Okay, so 1 by 3,
Extend hinge.
that could look like 2, -2, 1. And then 3 by 1 could look like
4,
4,
20.
20,
Yeah.
plus. Got it. Nice. And so the answer is just going to be 1 by 1. I said that the dot product of these two, basically it's just the dot product of these two like vectors, basically, right? So we get 2 times 4 is 8, plus -40, plus 1 times 12 is 12. So 8 plus 12, 20, -20, final answer? 1, 5, 1. That was kind of nice. Yeah, Brent,
No, I was just.
you're good?
My pencil.
Oh, I understand, like,
Yeah.
oh, you're,
That's okay.
you're good. Don't tell me what I did that. Okay, okay.
Hey, it's all right. The sub's rude if the Isaac yesterday.
Yeah.
Isaac, did you die?
Oh, I caught it. I got no problem with it.
I'm so proud of
But
you.
still, like.
Wow.
he's
Okay.
rude.
So, Today for practice, I have a worksheet for you because I didn't want you to have to try and do this on the computer with all these little things. I know, thank you. I have to go grab it from the copy center. So if you are not done with the quizzes, it's up to you which one you'd like to work on first. It'd probably be a good idea to finish the quizzes from yesterday first if you need to. So you can grab a Chromebook and work on that. But I'm gonna go grab the worksheets, we'll hand that out, and you'll be able to practice multiplying matrices. Look out, you know, I did. Maybe I can
It's
go.
a bunch of weird things. that we haven't met.
It's a bunch of weird things. You're right, it is a bunch of weird things.
Oh, yeah.
Whoa, how?
There's a matrix button.
There's a matrix button on the calculator.
Yeah, it's in this box.
Oh, I found a simple way to do it.
I can. Whoa. Name. Okay.
Whoa. What's that?
I can name first.
Yeah, fine. Why? Why are you
Oh
wearing
my gosh,
that?
you're doing a folding.
Have to.
I have one.
Why?
Figured it out, guys.
I never did this often.
Where's the space button?
I know, Doc.
Where's the space? No.
Whoa. That's like 9. That's like 8.5. That's very tiny. Wow.
Measure that. Why else was she out of here? You're down here in the next.
Yeah, probably doing the same.
Talking to me.
Please.
I only forgot when I take it out. When I took it out, when I took it
You're a very cultured teacher.
My grandma.
I have terrible news. I have terrible news. I accidentally wrote V.2 practice instead of M.2 practice. So I don't think I can come back up to this.
I guess you can't do it.
You're gonna have to get a new teacher. Please, when you grab this, will you fix the V, make it into an M?
Yeah.
Thanks.
Oh, I thought you
We basically did throw it away now. We gotta burn all of them.
Yes.
Gotta recopy them, because I hate trees.
You hate three?
Yeah, so I'll just recopy these, I messed up the V.
Let's go to a full set of tools.
Yeah, like.
Only a while. Come on, I don't need one, I have an answer. You good, you good, you good.